Hello, my name is Timo Drick. I'm an Android developer at 7 Principles. And we're going cutting edge to edge in Android 15 today, using previews and testing in Jetpack Compose to manage insets. I live in Germany, in Frankfurt. Here's an image of my home city. I'm doing Android development since 2010, full-time. So let's start. First of all of my slides you see today are also available here on this link. You can scan the QR code or just enter the link. I will first give you a short introduction what are window insets, and then we're going a little bit into problems when you enable edge-to-edge in your app. And then I will show you how you can create previews to see problems with your window insets. And after this, I will go a little bit into testing, how we can use tests to verify that everything works correctly. So let's start. Enabling edge-to-edge in your app means that your app now has a little bit more size. So before you enable it, the status bar and navigation bar is just black and you cannot do anything with it. And your window size of your app is limited. And now when you enable it, you can use the complete size of the phone, but you can also draw behind the system bar and the navigation bar. These different navigation bars and system elements are defined as window insets, and they are very easy. It's just the different sides or edges of the device, so left, right, top, and bottom, and just the size to this edge. So here are some samples. The status bar at the top, for example, there you see the current time, and at the bottom, the navigation bar. And then here, in this case, on the left side is the display cutout. This is the area where the camera is. You have also information about the IME. This is for the soft input keyboard. Or when you're using desktop window mode, then the system bar is not there anymore. It's called caption bar in this case. You get also information about these areas where the user can interact with the system. So that's not visible, but when you use, for example, gesture mode, then on the left and right of part of the screen, you can do this gesture to navigate back and forward. And these events at this point are also captured by the system. So if you have buttons there, maybe they interfere with the system elements. And of course, also at the bottom of the navigation bar, you have these tappable elements. So you can, there's a difference between system gestures and tappable elements. Normally, it does not make sense to just do a specific padding or something for just the status bar, for example. So there are some variables as it's in the Compose in the Compose API. It calls system bars, and then it will combine the status bar, navigation bar, and caption bars for you. Or you can use safe drawing, which will also include the IME and display cutout. And then you have safe gesture, which will include all interactive areas. And then safe content will combine everything together. So what is this talk about? I will show you a simple, perfect solution. No, maybe not. But I will make you aware of some common issues when enabling edge-to-edge in your app. And I will also provide you some tools to identify problems in your app. Also, I will provide tools that you can check if your content will overlap with insets. So, Google announced Android 15, and it's also announced that Edge-to-edge is now enforced for every app. So when you target API 35, you cannot, or you don't have to do anything. Your app will draw the whole screen. And if you don't do anything, then it will overlap with your screen, with the navigation bars of the system, for example. Even if you don't have to do anything, I would recommend when you do the effort to support edge-to-edge design, and you should do it, then you should enable it. Here in your activity, it's just one line of code, enable edge-to-edge. It was there before Android 15. It's supported a long time now. More or less back to 21, the same API level like Compose, with some restrictions, of course. The full capabilities are there since API level 29. When you put into the effort now to enable edge-to-edge in your app, you should use this line, so it's available on all devices, also older models. So what happens when we enable edge-to-edge? Here it's a sample app. We can draw the complete screen. If you don't change anything, you see here that our application bar at the bottom will overlap with the navigation bar of the system. And also the padding at the top looks not so great anymore. So what can we do to fix this? I promised you one simple solution. And this is just at the root of your Compose UI, you just introduce one window inset padding here. So this is a system API you can use, and you can choose what kind of window insets you want to have as padding. And here I selected the safe drawing, so I get padding for all system elements, including display cutout and IME in this case. So I put it here at the top of the UI, so this means that it will take care of every side. Maybe it looks not so bad. Maybe at the bottom you see this stripe where the navigation bar stops. But yeah, it works. Yeah, it's more or less a perfect solution. But of course, it means that you more or less just disable edge-to-edge. So I'm not sure. I hear rumors that there would be a thing of opt-out for an app enabler, edge-to-edge design. But yeah, with this line of code, you don't need this. So you can do it on your own if you want. But now, let's see how can we improve this. Better approach would be, in this sample app, we have two areas. So the upper part is this list view, and it's a lazy column. And the bottom part is the app navigation bar. And now we can add our padding independently. So we add this window inset safe drawing here to the content padding. In lazy columns, you cannot do this with a modifier, so we have to convert our insets into padding values, and there's this function .s padding values, and this will convert it to padding values, and then you can just use it. Or in our navigation bar, we can maybe directly use the modifier window insets padding, as you saw before. Maybe you see it already, but there are some problems with this. Now, when we do it like this, we have too much padding. So when we scroll down the list as far as we can, we see that the padding is too big here. And also the navigation bar at the bottom, our app navigation bar, it's also bigger than we want. So we have in the list view, we have this bottom padding, what we don't need, because the padding is already handled by our app navigation bar. And the top padding of our app navigation bar is already handled by the list. So for this, there's also here in the API of these modifiers for the window insets, you can exclude different sites. Here, for example, in our list, I use only the top padding. And for our navigation bar, I just use the bottom padding. And then it's all is perfect. And at least on this screen, it looks perfect. But of course, when we now change to landscape orientation, we have problems again. So maybe our app navigation bar is then on the side. And also, depending on if you're using as a user gesture navigation or button navigation, it depends. Then maybe you have at the window inset at the bottom or at the right side, and we did not do anything about this. So a better approach would be using this window inset consume API. So let's develop a small layout here. We do it just with modifiers, it's just to show you how it would work. So we have two components, and the first component will only consume the end. So, and with this modifier consume window insets and then consume first. So we use the window inset and only take the end. More or less, when it's normal layout direction, then we cut off the right side of it. And for the other part, we take the starting point and cut this off of our inset, and then when we use it in our code, we can just use the complete window insets here, in window insets padding, in our app navigation bar, and here I also used it in the lazy column. Unfortunately, this also only works half. It works for the app navigation bar because of the modifier I used for the padding. But when I use as padding values to convert in window inset and not using the modifier API, it will return the absolute insets. So it will not respect this consumed insets. So for the lazy column, we have to do it a little bit more complicated. We have to introduce a state here for the padding. And then we can use an on-consume window insets changed modifier. And there we get a callback every time when the window insets changed. And this modifier will respect the consumed insets. It will return the consumed insets, and you can then exclude it from your insets. And now it works. It will also work for different orientations, and everything is fine. Maybe one other thing here, you noticed, we have also keeping track of when we drawing inside of the status bar, for example, often when the user scrolls lists up and scrolls into the status bar is not visible anymore, or it's really you cannot really read it anymore. So maybe you should introduce some kind of alpha dimming or a linear gradient. I personally prefer a linear gradient. So at this window insets areas, to make sure that the system elements are still readable and do not interfere with your own content, you should do some kind of your linear gradient or something else, whatever you want, or alpha channel. Maybe it gets more complicated when you want to do animations. Here is one sample. We have this window inset off the right side with the navigation bar, and when our map view slides in, you see that the window insets will be adapted dynamically. So, yeah, I will not show you any solutions here, just want to show you that it's very complicated. If you want to go a little bit deeper into edge-to-edge and how you can implement it in your app, here are some links to the official Google documentation. There's a code lab and also a very good Medium article from the Android developers. Yeah, so you should look into it. But even the sample apps from Compose are not perfect, so they also have some. This is the reply app, I think. But I just want to show, do not want to blame Google. It's just I want to show you that it's really difficult to get it right. Yeah? And for every orientation and every use case, we get so much different screen sizes, configurations. So it's really hard. So now I come to my next part of my talk. Is about preview. So how can we as developer make sure that we know these problems? So since Compose was introduced, we have this previews in Android Studio, and they're getting better. And nowadays, for me, it's some kind of best practice to have a preview for every screen and also every screen state of your app. And yeah, when you want to make sure that it will also should work with window insets, then you have to include the window insets also into these previews. And of course, you have to try to cover every different possible screen configurations and also maybe different app states. So normally, when you add this preview annotation to a function, where so you can see the preview of your app screen, and it does not include any window insets. Since Android Studio Ladybug, now they introduced new functions to this preview annotation, so you can turn this Show System UI on, and you get some controls, so you can decide if you want to have button or gesture navigation, and if you want to have a camera display cutout or not. Yeah, it's a little bit limited, but yeah, it's better than nothing. But I wrote a small library to simulate the window insets. It was before Android Ladybug came out. So, and it's on GitHub, and it's published to Maven Central. And with this, you can also simulate the previews. And but yeah, that's now you have two options. You can the different orientations. You can use the preview annotation to configure this, and screen sizes, font sizes, and all these things. And in this edge-to-edge template from my library, you can also switch between button navigation or gesture navigation. It's also possible there to switch the orientation. So it's not only landscape and portrait mode. You can also rotate your device 360 degrees. So sometimes the display cutout for the camera is on the left or on the right when you're in landscape orientation. Even you can, yeah, in portrait mode, in theory, the display cutout can also be on the bottom of the screen. My library also supports this caption bar, so you can check if your app also considers caption bars. One more important thing I showed you already in the problems part of my talk. So when you scroll up the list the whole way, maybe the padding is not correct. So you should also include in your previews different scroll states for your lists. Yeah, this is maybe a little bit complicated, but if you do it, then you can directly see if your app handles this correctly. So yeah, I covered already this kinds here. Of course, you can use different screen sizes. Maybe you have also foldable states, IME and soft keyboard, font sizes, translations, layout directions. So it's so many different things. What can we do about it? There are custom multi-preview annotations and preview parameter. Maybe you know it already, but I will show it anyways. Here you can define your custom annotation. Here I just call it device configs. You can call it as you want. And you can then define different preview configurations here. And then you can use this in your, instead of the preview annotation, you can use this device configs annotation. And the preview in Android Studio will show you all different configurations. The other thing is a preview parameter provider. And here I can define a custom class with my different configurations for the preview. And then in my class for the preview parameter provider, I just return a sequence of my different configurations. And this then can be used in my preview. So as I said, I do not use the preview annotation here, I just use this add device configs. And in the constructor parameter now I can use this preview parameter provider. And then, for example, in my app state, I can say, when the config says scroll down, that my list is scrolled all the way to the bottom or not. And the other config parameters, I can do custom things here. For example, I could change the layout direction, or I can show different system bars or navigation bar, camera, all what I want. And when I do this for this app, then I get a lot of screenshots, but when I do it smart, I can cover almost every case and see if something, if there are problems. Of course, you have to do this for every screen and state. Here, for just one more sample, here I have the state when the map view covers the half of the screen. But maybe as a developer, when you change something, you do not want to look on all the screenshots. So we come to the next part, testing. And fortunately, there is a new plugin from Google. It's still in alpha stage, but it's called Compose Preview Screenshot Testing. And it do the tests on your JVM. So you do not need an emulator or device to execute this. And the important thing is you can just copy your preview things, your preview configuration to another directory, and then you are ready. So when you have previews for every screen with different configurations and window insets and everything, then you can just copy this file to another folder, and then you can record the screenshots and later verify if they change. Unfortunately, for my sample app here, it does not really work because I have some custom layouts which are not first frame pixel perfect. So as you can see, yeah, it looks not correct here. But maybe for your app it will work. But it's an alpha stage, so yeah, maybe we can find a solution for this. Of course, you can also use RoboElectric or yeah, maybe Paparazzi or Roborazzi to do the screenshot tests. And yeah, when you want to have the window insets there, then you can use my library to simulate the window insets. When you want to do screenshot tests on devices, you should consider some things. First of all, yeah, it only makes sense when you screenshots also include the system UI, the elements from the window insets. It is possible with the UI automator to do this, but of course the camera cutout will not be visible. And you can also not see the touch areas, so where are the system gesture areas, and also one more important thing is that the clock and icons may change on your even on the emulator or on the device. There are some solutions for it with this demo mode thing, but it will not work on all devices. So yeah, a little bit problematic. So other thing we can do as developer is just programmatically test if our content overlap with the window insets. And yeah, I wrote a library for this. It's not published to Maven Central now, but the code is already on GitHub, but I will publish it at the weekend, I think. So this code will not work right now, but next week it should work. And yeah, let's see. So when we want to test our app, we can use this compose test rule, create compose rule, and then in our test we can just create our compose content here, our app screen. And when you do this, then yeah, one problem is that it will not enable edge-to-edge. Of course, when you use an Android 15 device and target API 35, then you will do edge-to-edge, but yeah, normally it's not enabled. So, but you can do this just with this one line of code. So we have to call this enable edge-to-edge. And this will also work for your tests. And then my test library, so that it can detect where the window insets are, I need this semantics window inset anchor inside of the content, of the compose content. And then in your test, in the compose test tool, for example, let's test that our text components will not overlap with the window insets. So we define that we just use the semantics properties text, and on all nodes with the text, we do now this new function, assert window insets. This is a function from my library. And there you can specify which window insets you want to test. So in this case, I test the system bars and the display cutout. And of course, the app is perfect, so it will not find anything, but let's remove the padding for the status bar. And then you get an error in your test report. And it looks like this. And it will show you the node which is overlapping, so it's this required permission text. And in line 10, you also see that it's overlapping with the status bar and the display cutout. This library will also do a screenshot, but it's in the output folder. It will not be inside of the test report. When you test for overlapping, one other thing you should consider is when you have a list and it's scrolled up here, for example, then you see that it will, of course, overlap with the status bar in this case. But the test library checks if the scrollable content is scrolled all the way up and then excludes this window insets from this check. Or when it's scrolled all the way down, it will exclude the other parts. So it does it smart. You can turn it off with this exclude vertical scroll sites and set it to false. Then it will complain about this. Otherwise, it will not. You can also, of course, test if your buttons intersect with window insets. When we do it here and the button navigation is turned on, then it will work and it's all fine. But when we use gesture navigation, you will see that there we get a bug because the buttons overlap with the gesture navigation here. I would recommend for now just test for tab-able elements and not the gesture navigation. But maybe later we could also test just that some parts are overlapping and it's okay or something like this. And of course, when we now test this overlapping, we also want to test different screen rotations, 3-button and gesture navigation mode, font size, display size, layout direction, and much more. So how can we do this? Therefore, it's similar, more or less similar to the preview parameter provider we have in testing. We can also specify a custom class where we specify different parameters and create a list out of it with different permutations between the test parameters. And then also I developed a small tool which helps you to set up your test a little bit. So this is this device configuration utils. And it will more or less just execute some shell commands to turn the screen on, rotate the screen, switch between bottom and gesture navigation mode, and change the font size and display size. And after your test, you can restore the configuration of the device. So in our test class, to use these different test parameters, we have to use this annotation run with parameterized class. And then we also have a custom, our test parameters inside of this constructor of the class. And we have to provide this companion object, which will provide the different test parameters. And then, as I showed you already, this device configuration utils. And when we do this for the app, then when we have this set up, we can implement functions for every screen. And then we get a lot of tests. In this example, it's 256. And it's just, I think it's 3 or 4 test functions with the different screen states and screens for the app. By the way, this is sped up by 10. So normally it takes a lot longer to execute the test on the device. And this leads to the next part. And this is using Roboelectric for these tests for overlapping. And this is also possible. I tested it. In Roboelectric, you can run your tests inside of the JVM. You don't need an emulator or a device. Very, very good if you have CI and do not want to have a device farm or something connected. So in Roboelectric, it's similar, more or less, a little bit different. You provide your own list of different parameters you want, and then I do have this qualifier list. It's more or less the same like the preview configuration, where we can define different screen sizes or the density and stuff like this. And then in my test, I can use this. Also, I then have, in the constructor, I have my test parameters and these qualifiers. And I also have to create a companion object to provide these test parameters to RoboElectric. But the other part, it's more or less similar to the normal device test. So I also create a compose rule. And here in my setup section now, I use this runtime environment from RoboElectric to set the display size and stuff like this. And then in my test class, test function, I can use this preview library to simulate the window insets with different test parameters. I also have to include the semantics window insets anchor here, and then I can specify the normal tests. In RoboElectric, this local inspection mode is normally turned to false, but for me, I'd set it to true because, on the JVM, maybe some parts of UI will not work. But it depends. Okay, so that's the end of my talk. Short summary. So one important takeaway, edge-to-edge design is very complicated and you should not underestimate it. So if you want to support it, then take your time. And you have to, at least in 1 year. Using previews helps to identify the problems. And you can use the screenshot functions. So when you have previews for your screens, then it's very easy to do screenshot tests if you want to do it. It's up to you. And also, if you have put this effort into it, then you can also very easily do this overlapping tests. So because you have already set up your testing environment, and it's easy to do. Okay, so, here are some references. I wrote an article about edge-to-edge design on Medium, and this library link, and a lot of documentation from the Google developers, very good Medium articles also about edge-to-edge design and also testing. All my slides are here. You can then take the reference links from the slides. Thank you very much for your attention.